So my name is Aki, and I'm been a machine learning engineer for the last I would say 10 plus years. Been in the field for then 12 plus years, um, and done a PhD, done a postdoc. Was head of AI engineering at a hedge fund before, and right now doing teaching on Maven and running my own AI consultancy firm that builds sort of end-to-end solutions for companies in the US and in Europe as well. So I think the focus for today is like to try and sort of have a audit of the ML landscape and like what it looks like, and sort of things are getting sort of like mixed up with AI ML, and how to sort of like decouple that, and like to actually see how we become sort of ML engineer. So that's the main focus. Uh, so I've broken down the conversation into five parts. Like we look at like what ML landscape looks like, and then look at the three tiers of ML engineering, like what it looks like, and then we'll go into core skills that you need to have in different sections, and then your general learning part, like if you're sort of self-learning, and what to do and what not to do. And I provide some resources as well at the end. And while we are going through it, feel free to ask questions because you're a small group. We can have a conversation. So yeah, I mean, like unmute yourself and ask questions. So yeah, I think like if you look at generally current landscape, like I would say like there are like three main areas we can focus on. There's the foundational models that are getting sort of like since ChatGPT. It's like quite a lot of foundational model research that's been done, and quite a lot of firms like OpenAI, Anthropic, Grok has made so much progress, and it has come to the point that not a lot of firms or companies are focused on training foundational models. Either you fine tune something, unless you come up with a different sort of a architecture, you have to sort of focus on the building something from scratch. So the most use cases are coming from you sort of like fine tune these models and sort of like sort of make sure that you can use them within your sort of application. Then you have the production systems shift, which is like if you look at ML engineering right now, it's like mostly around systems rather than modeling. So modeling is important for sure because without that ML doesn't exist. But I think the most of the hard problems are on ML ops and on monitoring, etc. So if you look at it, um, the third point is like agentic and multimodal explosion. So things like MCP, A2A, and also things like OpenClaw that's coming out, like very agentic tools that are coming out that can sort of like do a lot of things super fast. And so that's where you'll see most of the transition happening right now. So I think like it's a really interesting area to keep an eye out. And I think like if you look at these sort of um, the changes in the market, like this sort of derives three types of engineers. So these are like tier one, tier two, and tier three, I would say. This doesn't sort of I would say like the three types of engineers, and you have the foundational model engineers like who may work for places like OpenAI, Anthropic, or even like research places like if you take DeepMind, Stanford NLP Group, etc. So you have like folks who works on the foundational layer, whether at like training models or actually thinking about new architectures. And then there's tier two, applied ML engineers. These are um, sometimes within the big tech firms, but also mostly within other firms where you sort of use these LLM tools like and then fine tune to your use case, build RAG systems, agents, etc. So this is quite this seems to be the most common sort of tier, like where you have most of the jobs, and then you have like tier three, which are ML platform engineers. These folks are very hard to find, similar to like foundation model engineers, but because to do ML platform engineering, you need to have very strong software engineering or data engineering skills, and then on top of that, you learn how to sort of like serve ML models, how to reduce inference cost, etc. So that's the third type of sort of engineers which are out there in the ML space. And if you look at it, um, out of these three, the most the highest and the easiest as well to find a job is in applied ML engineer roles, where you have like a lot of openings and like relatively easy to get into these kind of jobs. So let's look at like each section like one by one. So you have the foundation model engineers. This is like where you'll have either PhD in machine learning, or you've done like extensive research, or you have sort of been as a research engineer for a while, even if you don't have a PhD. And this is where you sort of build uh, connect clusters of GPUs to train foundation models or fine tune foundation models, etc. So OpenAI has these engineers, Google has these engineers, any kind of a leading model developing company would have these kind of engineers. Relatively hard to find, but because it requires like not just one type of knowledge, you need to have machine learning knowledge, you need to have infrastructure knowledge, you also need to have like software engineering knowledge. So you probably need quite a few set of um, skills stacked together to land these roles. So I wouldn't try here if you're new to the role, new to the domain, but this could be an interesting area. Purely because um, because they pay as well, because like to the lack of um, available folks who know this, who have this kind of skill set. So if you look at the skill set, so they do like research into this, like for example, thinking about like transform architectures and different types of architectures. They'll figure out like what sort of changes you need to do to get the best out of the models, and do distributed training with across TPUs and GPUs, RLHF pipeline engineering. So you do that as well, and sort of experiment and build sort of eval frameworks around the training pipeline. So this is engineering wise, it's an interesting field, but relatively hard to land these roles. Then you have applied ML engineer roles, the one we discussed earlier, which is I think if you are coming from a boot camp, or if you're coming a few years of experience in industry, these are like the easiest to land because a lot of firms want to now apply AI into their sort of workplaces. So it's amazing role for a beginner to land. Like you might need at least like 6 to 1 year worth of experience, like building ML projects, at least if you're not working in a company. I think this is a great opportunity for you to sort of land and sort of get started in the industry. So if you look at what they do, like you fine tune foundation models, like you take OpenAI models or Anthropic models, you fine tune them to your domain knowledge, and then you can build RAG pipelines, like to for your custom data sets, and you around that you build the right kind of monitoring and the scalability as well, like setting up the infrastructure that is needed, and apart from that, you like the more advanced version of this role is like cost and latency, like managing that aspect as well. So I think like this is I think the easiest job to land, comparing all the three jobs. And the third one is tier three. We spoke about ML platform engineers, which are um, the folks who would have the best kind of software engineering knowledge, and but also the data engineering and the DevOps knowledge. So where you'll have sort of the you have best of both worlds. You understand like how ML works, but at the same time, you understand how to set up these training pipelines, etc. You may not need to have like deep, I would say, machine learning knowledge compared to the foundational model training folks, but still, you probably need to have really good software engineering foundations, and then understand ML fundamentals and ML ops. And you can sort of like join most like Meta has specific team for this. They hire specifically for this role, and I know Google has as well. So these roles are like I think the skills that you have, you develop in these roles, very easily transferable for different domains, because you definitely have the skills of a general software engineer to play a massive role. So I think this could be really interested in transition role for experienced software engineer or data engineer, I would say maybe coffee. This could be something for you. This could be if you look at like the job adverts at Meta, you'll see this role pop up a lot. ML platform engineers. And yeah, if you're a software engineer with a lot of experience, this is a role that I would look at if you want to get into ML. And to get there, you probably need to have a bit of flavor about ML. You don't have to go into in depth, but you probably need to understand at a I would say like a beginner level at least, or maybe medium level experience to get started with these roles. And on the job, you can learn a lot as well. Sorry. Um, yeah, I think like irrespective of the roles that we looked at, but if you want to be good at ML, I would sort of follow this sort of like the pathway. So I've broken out into like 5 layers. The first layer is like maths and statistics. Um, so I think like irrespective of the timeline that you take, you can sort of think about this as okay, you learn like linear algebra, matrices, vectors. This is the if you take any kind of ML sort of a studying guide, you'll have maths and statistics, and then you have program and software engineering skills where you either you pick Python or TypeScript and you stick to that and like going deep, understanding like how to sort of build software and the general sort of software engineering skills like DSNA, data structuring algorithms, Git, versioning, all sorts of software engine related skills that you need to have, things like Docker, Kubernetes, etc. And the third one is like ML fundamentals. So after you learn the maths and statistics, you can easily move into supervised, unsupervised learning, how to implement neural networks, and then move on to transformers, RLHF, etc. So you learn the ML fundamentals as a third step. Um, and the fourth being, we looked at like what sort of things are needed in the current sort of era, which is like the foundational model skills, like you focus on prompt engineering, RAG systems, fine tuning, for example, LoRa and CLoRa, like which is to sort of fine tune models to like reduce the size or fine tune it to a specific domain. And then also multi-agent systems like React and the different types of multi-agent libraries like LangGraph, ADK, etc. You sort of look into that. So that's the layer four sort of information that you need to focus on. And layer five is like the final layer, which is like production and ML ops, or some would say LLM ops, where you sort of focused on deployment, sort of cost and how to do observability, and you double on a specific cloud platform. I think so. This is why I asked the question, Coffee, like to understand what sort of the expertise that you may have on a specific cloud sort of provider. I think you pick one of the three, basically AWS, GCP, or Azure, and you sort of like learn 80% of that stack. And when you have the knowledge, you can sort of easily transfer into other domains as well without an issue because they have very similar products. And I would like recommend AWS or GCP, and you stick with that until you sort of understand the ML tool stack around that, because that gives you relatively easier transition into ML deployment sort of roles. And that's the final aim. So this should be like done super fast, and I'll explain like what that means. So if you look at like ML sort of roadmaps, um, my sort of experience and gut feeling and like seeing a lot of this being done is like, and I've sort of like broken down into like not to do things and like how to do it as well. So what not to do is like spend 6 months on theory, forever on theory, math, stats, like for 6 months doing different kinds of courses. That wouldn't get you where you're gonna go. Like you can get there, but it's a long period of time. And also following like a linear roadmap, the maths basics, like so these things would be ideal for undergraduate degree, but if I sort of like want to have like um impact super fast, I wouldn't do something like this. And obviously don't get stuck in like the certificate loops. You do a lot of certificates but do less building, which is not ideal either. And I've seen like this this so the this you chase like flashy objects, like different kinds of libraries that come up, and you try to like sort of learn every library that comes up. It's not going to be easy, and you wouldn't have time to sort of go into a specific library. And also I've seen folks talk about like feeling ready um, before applying for jobs and before applying for like before sort of deploying projects as well. So there's some of the um, things you need to avoid, and I've sort of noticed sometimes I'll do this as well, like, but I have to like pause a bit and figure out, okay, I shouldn't be doing this. So the best way to learn is like start building. It doesn't matter like the knowledge that you have. Like there are so many AI tools right now, things like Cursor, Cloud Code. You can get started super fast and start building. And when you get stuck, then you go and sort of learn. Like so, the idea is like you learn just in time. Like so, you get stuck, you start learning the specific topic rather than the other way around, which is a bit hard at the beginning because you don't know what you don't know, so you get stuck super most of the time. But with time, that's going to get easier because your sort of brain get wired in a way to like understand ML problems, and then you can debug much faster. And I think like ideally, you should be learning and building at the same time so that you cover both sides rather than learning everything and like willing to like sort of build at the end, because like when you start building, you have forgotten what what you have learned at the beginning. And then GitHub. So like if you are not working, make sure like you have a public GitHub repository and start sort of committing projects like whatever stuff that you're learning. Like keep a super active GitHub profile, like projects as much as possible. So that's gonna be your resume. Like it doesn't matter like what you say in your resume if you don't have like projects on your GitHub, wherever you. I mean, doesn't have to be GitHub. It could be any other platform, but I think like you need to have uh, your projects public as much as possible, and also deploy projects. Not um, like just clean code. You have to get into production, like see it in action. And if you don't want to put a public URL, record a demo and put it out there so that others can see that you have built something that is interactive enough. And in the bottom line is like you'll never be ready. I think like just always new things coming up, you'll never be ready. So the idea is that you uh, ship things whenever possible, and you start like learning while you're sort of building. So there's this concept called building in public. So you build things and put it out there, and that sort of like increase the luck surface of you getting opportunities in the area of machine learning. So that's my sort of like approach for like studying and learning machine learning has always been the case. Whenever I learn something, I share my so before LinkedIn, like I used to write a blog, and now I write a lot on LinkedIn, etc., and like put stuff on GitHub as well. So make sure that you have like a public profile in some way about your learning. That's gonna like help you a lot. So this is like one way you can sort of approach this from a portfolio point of view. Like you sort of like create this um, the first project being like looking at the foundations and building your first project, like looking to like ML, NumPy, Pandas, the basics of machine learning, and then sort of try and build something and deploy that model. And you can create a live API as well. Second is about foundational models and RAG. So you learn LLM APIs, about prompt engineering, different types of prompt engineering, vector DBs, and you can deploy like a production grade RAG application and sort of expose that to for users. Third being agents, especially multi-agent systems, like looking at LangGraph, and then also looking at different types of MLOps, like how do you sort of do tool use, like how do you create external services like MCP servers, and how do you do agent-to-agent communication. So you sort of focus on those skills and build a much more sophisticated product that sort of encapsulate your software engineering skills, but also ML skills. And the fourth being portfolio, you sort of combine all of these skills together and build something in a specific domain, whether it's computer vision, natural language, MLOps, or multi-agent systems, and like build something that is solid enough, that has a lot of meat, so that you can sort of talk about like the production issues that you faced, the cost issues that you faced, how do you reduce cost, and then the latency, and all sorts of information that you can pack into like a specific project and then put it out there. Do 2 to 3 of these, and then definitely you'll find some sort of a job with a at least at an AI application layer. So this is how we like sort of if you're going down the road of like landing a job, this is how what I would do. Yeah, and yeah, I think like the 5 principles of sort of like your learning path is like first, as I said earlier, build in public, like build stuff in public, on GitHub, LinkedIn, X, etc. You sort of put the stuff that you build. And then the four signals we looked at. So every project should show like problem framing, like what's the problem that you're trying to solve, system thinking, and the constraints you had to sort of like manage, cost, like latency, etc., and put clear documentation. With AI now, this is super easy, but I've seen enough that people don't do this. Like write a really good README. If you can write a blog post as well, so put information on like what you build and what's the outcome of that and how you build that. So it's going to like give you a lot of credibility because the more and more uh, with the AI building a lot of code, it's relatively hard to sort of manage what's been built. So if you can sort of document that, that's gonna sort of take your project a long way. Third being deploy things like you can use AWS, GCP. There are free tiers in that, so you can deploy something super easily. Or there are other services as well. So get it out there so that others can see that as well. It's not just on your local computer, and then focus on outcomes, and not necessarily inputs. So I've seen like even like not related to this, people sort of talk about like I applied for like 500 jobs, 1,000 jobs. So it's like the you can like try a lot like that, but like you have to sort of learn and sort of improve like from outcome point of view. So and if you can get one of your projects to like solve a specific problem, that's going to go a long way rather than doing 10 average projects. So that's something I always try to do, but it's relatively hard because you're like look at your first project and like try to improve on that in the next project. And the fifth one being is learn just in time. So you don't like learn everything in one go. You learn as you sort of build things. Like when you do projects, when you hit problems, you start sort of building that. So that's my sort of take on this. Like if you're sort of because the ML and AI space is quite broad and there's no end to this. Like you can learn so many things and you can forever be learning. So the best thing is like to pick a domain, pick a project and start building things. And when you get stuck, you start expanding from there. And then that's how sort of like most of the people are working and learning right now. Um, and yeah, so I think the for resources and like sort of next steps, I would say. So you can sort of look at these resources, Fast API, Deep Learning AI. Fast API has like a really good free guide on like how to like learn deep learning, especially. And they also have an AI course, not I haven't tried that yet, but I've seen they've deployed on Amazon. But they have tried the deep learning course. It's really good. And deep learning AI. So they have like free short courses on LangChain agents. They are a bit salesy, like they have like in a way that they bring on like new projects, but at the same time, their content is quite good. And so if you need some sort of introductory course, you can get it for free. And Hugging Face on Learn. So Hugging Face Learn has so many free courses and I highly recommend trying it out. And Full Stack Deep Learning, there's another sort of website, and obviously follow Andrea Karpathy. He's one of the, I think he was head of AI at Tesla at some point. Really great guy, and he built these tutorials a lot on how to build LLMs from scratch, and like training neural nets from scratch, etc. So it's amazing stuff. He's really knowledgeable in this space, and also he's a really great teacher as well. So you can learn a lot from him. Like even just watching one of his videos is amazing. And you have like other resources like for um, archives, like for papers, and there's quite a few newsletters, like especially the batch from deep learning is amazing. And there's quite a few podcasts. I listened to one of them, and you have a lot of communities on Reddit, machine learning, and then there's Hugging Face Discord. You can sort of like find builders. And I think like even with open to, I'm sure like there's a Discord channel for that, so you can sort of like talk to a lot of builders and see what they're building. I would say like you stay in these like communities and you can get to learn things that you're interested in. And there's also action plan. Like I think like depending on where you are in your sort of learning journey, you can follow this. The ideally similar to what we covered earlier. So you try and like pick a project, and we then start a GitHub project on that. make sure to join one of the AI communities, whether it's Discord or Slack, start building. And in the first month, I would say deploy your first project. Doesn't matter if it's not perfect, like get it out there and write about what you learn and like document as much as possible. And try to like apply the 4 signals framework that I discussed about, like the around the impact, the constraints, the problem that's solving. Think yeah, the problem framing, system thinking, real constraint, and documentation. So you cover those 4 angles in the first month. And the next 3 months, like complete 2, 3 projects, get everything to deployment, and start applying for jobs. I think like if you're looking for a new role, start applying for jobs, and if possible, contribute to open source. That's where the best learning happens. And if you're an open source contributor, you get a lot of credibility in the industry. Like I mean, OpenClaw is one of the good examples. You can try and go and contribute. It's an amazing multi-agent system to open source tool, and there's a lot of um, sort of community around there. I think they've reached 200K stars on GitHub, so it's quite amazing. Yeah, and I want to like sort of pause here and stop here because the last slide. So I think like the key takeaways are um, s- um, systems and production. Like I think like ML engineering and AI engineering in 2026, it's all about sort of systems thinking rather than just models. Like how do you build something that can sort of handle like a lot of users, and also like making sure that costs are sort of handled as well. And then second point is know your tier. Like look at like what is the easiest transition for you, whether it's a foundational engineer, foundation model engineer, or applied AI engineer, or a infrastructure ML infrastructure engineer. So based on that, you sort of like plan ahead and sort of start working towards that. And third being build a portfolio rather than doing certificates. I highly recommend this. Like try to build things, get things out, and talk about it publicly. And yeah, we do have a course as well on this. Probably get an email on this. Like we do run a bootcamp on this. If you are interested in learning, but yeah, when I want to post here,